Okie dokie. Let's see about getting started. Once again, I left my headphones in my bag, so I'm just not wearing them at the moment. We got for music over here, though. Headphones, be surprised how little I need them for things, you know? It's mostly because, I mean, nobody else is up here right now, which is lucky. But, yeah, that's how it is. Modeling. So we're at some really tricky parts, you know? Because, you know, I'm trying to. So you might realize that the top teeth are not supposed to quite look like that, right? We want it to display flatly across, regardless of what the actual thing is, you know? So that's why I'm a little curious. I copy this, and what happens if I put in the vertex shader instead? Okay, it hates it. Color instead. Right. I really have no idea what to do here, is the thing, you know? I really do have to just look this up. Because I just don't know. And there's just nobody who does that I know of. So I will have to find them. So we'll see. Display on mesh. Flatly like object map like in Blender adult. I can't. I don't think I can copy a shader directly, believe it or not. Um. Ah. We would really like Godot to be emphasized. Bum ba bum bum ba dum. Nope. Um, Overlay an image onto a mesh instance, huh? It really is just tricky. I guess technically I could leave the music on, but I just don't kind of feel like it right now. The tricky part is that see, I have these parameters that allow me to move this around, you know? But the problem is that it deforms because of the UV map, and I don't want it to do that, you know? And it's hard to figure out how to make it not do that. Um, Yeah. Cause oof. Yep. Just tricky. Cause the thing is that gotta get it so that these things ignore the UV map, which doesn't make sense normally, you know? Um, I don't know how or why Blender did it. Oh, hi Sharky. You're cute. Aw, you're double cute for that. Um, how to have shader ignore UV map? Oh boy. Um, yes, Sharky. What do you need? Oh, you said crunchy. Adorable. I'm just trying very hard to. You saw. Yeah, you're adorable. I really don't know what I'm doing here. Because I've got to get it so that the mouth. Because, like, this is how it should display. Can you put it in the box? Okay. Becky, you're just so adorable. Don't know how anyone can resist you. But yeah, I've got to get that working. Or thank you, Jake. Because I can obviously replace the mouth with like that. Ooh. Um, sure. I really obviously the way to get it not to use the UV would be to not use the UV, you know? But I don't know how, you know? If I were able to, it's like a point coordinate work. Oh, maybe. Okay. Um, this could be a lead. If that's UV, alright, so what I think is happening right now is that it's just really, really small, right? So what if I multiply, um, transform vector to multiply, okay, vector to multiply. I will put, maybe we'll put it like 5 times as big. Is that something that works? Maybe 100? Okay, some of these dots seem to be changing when I do this, it's the thing. But the problem is, yeah, you can see on this texture here that uh, so if these are zeros, yeah. But what if maybe instead of point chord, we try a different thing, right? Vector, no, it would probably be an input fragment. Screen UV, test that. Okay. Alright. That's, not quite it. But look at that. Oh. Now what I need is for it to shrink. Right? Add node, multiply as a vector too. Multiply by 1. And it goes like that. But if we multiply by 0.5 on the x, it might have made it longer, okay. If we multiply by 2 on the x. Alright, that's gonna make it shorter now. Is this the top tooth texture? Must be, huh? No, hey Grace. I'll go do those sit-ups, yeah. We're making a bit of progress, right? The only problem, oh golly, is that that does not need to follow the camera. Zzz, gotcha, you're EP. Alright, but we found a solution that will start to work. Maybe in stream, but not chatty. No worries at all. Okay? I probably should just put the music back on, huh? So maybe a bit quieter. There we go, so it's not quiet. Maybe Passenger Princess would drive back to KY. I have to assume means Kentucky, but I really don't know for sure. Could be anything really. And we're going to go full body. We have not had much exercise while you're gone, Grace. Though I'm still getting some from walking to places on campus and such. Oh, my hair's a mess. It's just 15 setups. So doable. 1, 2, 3. 4. 5. 6. 7. 8. 9. 10. 11. 13. 14. 15. There we go. Okay. Thank you, Grace. And of course, thanks for showing up, too. But yeah. We are completely able. So screen UV is not the one we want, we've realized, because that makes it map to wherever on the so we're going to want does normal work? Oh, maybe. Oh, never mind. Normal also depends on which way it's facing. Okay, and that's vector 3, huh? We want a vector 2 anyway. Golly. Green UV is kind of the best we've gotten so far, unfortunately. Looking very closely to see which ones are vector 2. Point chord is kind of the best we have so far. But that one is a bunch of points, I think, is the problem with it. UV doesn't work for obvious reasons. Viewport size is pretty sure just normal. Or just not relevant. So golly. UV would be good, you know? If it didn't suck. Right? Let's see. Gonna need perhaps how to have texture always facing forward. Golly, I don't even know what. The problem is I don't know how to ask for things, you know? Don't know what I'm looking for. Green UV was the closest we've had, right? And that's because it just puts it onto the screen rather than onto the object, you know? And then it's bounded by the object. Which is not what we want. No, no, no. UV doesn't work because it distorts based on the UV, and we don't want it to distort at all. We want to give it a position, like something. Maybe we try just giving it a vector J. Vector 2 constant. Then we put both of these at 1. Make this a cube. Darn. 0.5. Still nothing. Golly. Oh, that's fine. It can be displayed as a color. Let's try 2. Gosh. I don't think that's gonna work. Golly. Blah, blah, blah. What if we, like, tried this, you know? See what it did. We'll just go try all of the things until we get something. Gotcha, so that one won't work. Invisible layers, maybe? Exposure. Golly. Hardcore. Ah. What? Normal. You can see normal doesn't work. Do that. Alright. Alright. Normal or node position world. Tangent could technically be promising, but no. Grr. Literally time. We can make it blink periodically, which is not what we want. Although, I am curious. You want me? You're adorable. Golly. See, it has to look like this, huh? It has to be a whole... Golly goshness. Textures, maybe? Function to be applied on texture coordinates. Interesting. Scanning. I wonder what this is about. Because none of this seems to actually do much. Scaling. Scanning. Yeah, it does do the thing for the offset. One. This doesn't seem to do what I'd hoped it would do. Curve texture. Cube map. Curve texture. XYZ texture. Linear scene depth. World position. Oh. I don't know. Feels like to me. This is the UV map as a vector too. Or it represents all the range of points, right? Do I get to see where on that it is? Guess not. Oh boy. But if I were to try like a texture 2D parameter, you know? That doesn't do it, okay. I can hope. I'm allowed to hope. Thing is, I need it to like just... Oh. Here's the thing. This is what the UVs look like, right? The outer part we don't care about. We only care about the inner part. These two round bits. And it just... Oh boy, it just does not work for it to be this shape. I can't just make it into something I need because I don't know how. So tempted to just make the inside here transparent and then add a new like canvas texture in Godot. Then I couldn't guarantee it lines up. Oh, sorry, the tracking must have frozen there a bit. Golly. Vector. Oh, color. What would happen if I did like this or something? Okay. Now this is curious. So the color here definitely does represent something important, right? I think I remember seeing that this is from 0 to 1. So if I were to make it that's not it. But if I were eh tried like that. What happens? Okay. Am I squishy? I guess so. Oh, okay. She's cute. Don't know what you're talking about. If I got a 1, what happens? It gets very wide, okay. 0.5. Yeah, this just doesn't quite work out, you know? I wish I could have it just put the texture there without worrying about the shape of the mesh, you know? Because in Blender it does it, and I don't know why or how. But if it didn't, then I wouldn't have this expectation that I'd be able to. But it's clearly possible, so I have to, right? Because you see, this is the same mesh. It's the same exact shape. The tooth, I don't know what's up with the tooth. I'm trying not to think about it, because I got mixed around at some point, and I don't know how to put it back. But, it's good enough. The only thing is that, like... yeah, over here it doesn't matter as much. I'll fix the tooth in Godot. But, like, you see here, I have texture coordinates, and this here vector is different. Like, I'm able to... I don't think a mapping node exists in Godot is the thing. Right? Must have from the input to the output, huh? It doesn't help, because I need it to not do what it's doing, you know? Golly. You see, it uses the UV mapping by default, right? Which sucks, but I get it, I guess. If we put this so that it's from 0 to 1. Good morning, Destroyer. I hope you're well. I'm trying really hard here, but it sure is difficult. Because, see, I need it to be like this, but different, you know? I need it to be specifically like this. And we can ignore the way the tooth is. As best as one can be at this time of day. You know what? That's so real. Oh boy. I have a lot to think about. Tomorrow shouldn't be too hard. But golly. Thursday will probably be quite hard. I don't have work, which is nice on Thursday. But yeah, right now I'm trying to figure out how to get this to just like stop using the UV map, you know? And I've gotten close. Right? I mean, what happens with this one? This one was one that depended on the viewing angle, didn't it? Yeah, huh. It's just that I can't rely on the UV mapping because I never set the UV mapping to be used for this, right? So it just doesn't work so well. You can even see there, up here, it just doesn't look good because it's not meant to be using the UV map. It's meant to be using, like, a position. But I can't figure out how to get the position to actually do the thing. This here right now is data, right? But if we set it to be a color instead, nothing changes. Okay. Like, first I've got to get a thing to stand in place of the UV mapping that makes it all, like, flat, you know? And the closest I've gotten to that is with the screen UV. And you can tell what the problem with that is, right? It doesn't move with the viewport. Like, I'd like it to just stay up there, but it can't, because it's tied to the position of the screen. You know? But it's, so far, like, the best one of the inputs, at least. Point coordinate. Just make a bunch of dots everywhere. Alright, and I'm trying to figure out what I need to search up to help figure out the answer to this. Right, something like screen UV, except with Godot. I put Godot twice. Use screen UV and keep it fixed with the object position. And nobody said anything, darn it. What if we take the screen UV and do something silly like add the screen UV to the regular UV? What even happens? Okay, it gets worse, I guess. I should have expected that. Yeah, golly. Because the screen UV isn't the answer. It's just the closest I've gotten so far, you know? Texture. If I put that screen. Nope. Texture 2D. What about this is... incorrect. If I were to add a texture 2D node. Alright, texture 2D. No, that's the wrong one. I want this sampler 2D. I think. What about texture 3D? No, stop. Texture 2D parameter. Image. Can I put that in the UV? No. Okay, then this just isn't worthwhile. Ollie. There's just no winning, huh? Texture map we can try looking for. No. What if we're talking about something else? I wonder what... What happens if I generate the map? Okay, it gets worse. And it doesn't get better. Ollie. Don't even know what to do. Create debug tangents. And see the way things are shaped. Okay, well, I'd like to go get rid of... Oh wait, debug tangents there. So there's that. Ollie. Yeah. Although UV map is weird. I don't know. Fucking UVs. Um. Golly. Research mem. Trying to. I don't know what I'm doing. How to display texture without using them. Try planar mapping, huh? Okie dokie. Here, I'm gonna pause this. We'll take a quick little look at this video. No idea if it'll be good or not. 10 minutes, 5 minutes that is. Ah.
Texturing meshes called triplanar mapping. This method will allow texture meshes without having to do anything involving UVs, making it a great way to apply textures to procedural meshes. First off, we should quickly go over the
Yeah.
texture meshes.
Okay.
The idea behind texturing
this could be what we want.
polygons that form a mesh, and we want to be able to plaster an image over each of the polygons to add extra detail and provide certain material information. UV mapping does this in a very simple way. We assign each vertex a 2D vector called the UV of the vertex. This 2D vector corresponds to a 2D coordinate on the provided texture, allowing us to map a polygon into texture space. While UVs are by far the method that offers the most freedom with texturing meshes, you quickly run into some problems. First, creating UVs can be a lot of work. Even in a good 3D modeling program, unwrapping meshes can take a long time. It's especially bad when you're working on procedurally generated meshes. In my previous videos on procedural generation, I avoided adding UVs to the meshes for this very reason. It takes a lot of annoying math, and for objects like a sphere, there really isn't a great way to do it. This is where triplanar mapping comes in. The idea behind triplanar mapping is that instead of using a UV value for each vertex, we just use the vertex's position instead. This allows us to texture objects without having to add UVs, and it also allows the texturing to be more dynamic. This allows us to move, rotate, and scale this object without the UVs getting distorted. I think this technique especially shines with procedural meshes. Here, I took a procedural terrain from one of my previous videos and applied a basic
Interesting.
I have so any surface facing up with section of grass, any surface facing toward the side is textured with rock. As you can see, it works just fine, and I didn't have to do any annoying UV math to get the effect. Now, Godot does have a triplanar mapping in its default material. The only problem is it's very restricted and it won't allow you to make something like this dynamic terms of it. So in this video, first I'll quickly recreate triplanar mapping as Godot has it. Second, I'll add the option to have 3 different textures depending on which way the object is facing. Third, I'll add in some other options, such as letting you have a texture that only appears at the top of meshes and a value that controls how harsh the transition between textures is. So let's get into it. I'm starting out with an empty spatial shader material attached to a default sphere. We're just going to be using the fragment shader for this, so let's immediately define it. The first thing I'm going to do is get the vertex position. I'll store it in a vector called vertex. This is going to be defined as the inverse view matrix multiplied by the vertex constant. By default, this constant is a vector 8, so we first need to cast it to it.
Okay, so inverse view matrix times vertex. Let's get rid of all this. In view matrix, huh? Okay, so what if I made a new just regular shader, then made it inner 2, then we want alright, and then here we're going to try thought I was able to put that in there. Well, anyway, vec4 vertex invert in view matrix times vertex. Okay. Let's just start.
With vec4, with its fourth value being 1. Our vertex variable now stores a will.
As a vector 4, that is. And of course, it does need to have a 1 in there. Maybe make that a float just in case. Yeah?
Coordinates of our position. Before we do more in the fragment trigger, we should quickly define a uniform sampler 2D that I'll just call texture x. You'll see why I'm naming this later on. We need to give the texture the repeat enable.
Source color, repeat enable.
Vector, assign the uniform whatever texture you'd like.
Okay, uniform sampler 2D. Texture 1. Source color. Repeat enable.
I'll just be giving it a basic texture.
Alright. And we are going to... Can I put this? Yeah. This won't do anything yet. But we can put the top tooth texture here. Preemptively.
Back in the fragment trigger, we'll save the texture to a variable called color x. For the
Color X.
use vertex.zy. And we want to quickly make sure we're only getting the RGB.
Okay, so now we're making a vector 3. And calling it color X. And then setting it equal to a texture of texture X and vertex.cy. Okay. Texture 1 and what? Vertex.zy, huh? And then .rgb to make sure it is a vector 3, right? Okay. Yes. Good news so far.
Values of the text. Test this out, set albedo to a sample color. As you can see, we're getting the desired effect, only along the one axis of our output. That's because we only sample texture once along the...
Okay, albedo equals color X. It's mostly nothing, right?
This is the UI plane. In total, we actually need to sample it 3 times. So after we define vertex, but before we sample texture, let's create 3 variables, uvx, uvy, and uvz. Each are vector 2s. uvx will use vertex.zy.
UVX, UVY, UVZ. Okay. So you're making math? Yeah. Yeah, it's gonna go right there. It looks not good, I will say. I'm doing my best, but, you know, there's only so much I can do. It's too bright is one thing. I'm gonna have to work on that in a bit. But not now. Yeah, so 3 vector 2s. UVX, UVY, UVZ. And then
uvy will use vertex.xz.
vertex.zy. Is I'm assuming it's just going to be the other 2 on each of these, so we try vertex.xz and vertex.xy. Let's see if we're right.
And uvz
Yep.
Then we'll split the texture sample we were doing before into 3 separate samples. The second and third samples will be called color y and color z respectively.
Hang on.
We were doing before into 3 separate samples. The second and third samples will be called color y and color z respectively. Then we'll
A, Y, and Z.
with the corresponding UV variables we just created.
Gotcha. So put these down here. We're going to copy this. And we're going to B. We go Y, Z. And here we go U, V, X. U, V, Y. And U, V, Z.
Finally, to combine all these equals together, we'll set the albedo to add. This means adding them together, then dividing by 3.
Okay.
Here's what the effect looks like.
Average them together, so oh. You see that there? What'd they do? Yeah. So that's a good thing, right? Because you see also how it's not deforming near the edges and or anything. That's good. This is what we were after. Now, the one problem is that we do need it to be up there, usually. Okay, I get that. Yeah, because if we look at the UV mapping, you can see how it's all, we can ignore the outer outline, because that's not part of the material. This material only knows about these two inner ones, and in Blender, like, Blender doesn't use them at all. These are not set up to use the UV mapping. You can see here, instead what we did was we had a particular object whose position we tied to the position of this on the texture. That doesn't quite work the way I expected in Godot, which is why we're doing it like this. And so far, so good. You know? It's on the thing. What I want to try is to get a uniform float T1 offset X, and then form float T1 offset Y. That's supposed to be next. Now, if that's how I think it is, then yeah, we get these parameters. Awesome. So then let's try so if this is a, I think here is where we want to, vertex.zy plus v1 offset x, right? And then plus t1 offset y. Then, okay, that's not quite what I expected. That's fancy, huh? Okay. That 0.5. We're going to instead, can I rename this easy? No, darn it. We're going to call this top teeth text. And then we're saying TTH for top teeth. Right? Right. And then offset X didn't do much for us. So it might be Z that we need to add that to instead. But it's gonna take a second. Actually, instead of copying it, is actually just faster to go like this until we get to that point where we go and just copy the whole thing over. like this. Okay. That's not quite it. Oh wait, the texture got reset. Top teeth one up. PNG goes here. Right. So we saw before that moving by X didn't do it for us. But if we instead put that there, just for testing. Also, no. Gotcha. Alright. Then it looks like the offset X isn't going to help us. Seems like the only thing that matters is this one. Right? Everything else doesn't really cooperate so well. Then we will also say uniform slope scale. And then we will try these one at a time. But if it works with this one, then I'm happy to just mess with this one alone, right? Alright, we need to put this at 1 to start. Then, yeah, okay, it's kind of backwards from how you'd expect. Oh, and this should also be PTH scale instead of just scale, because each one's going to need its own. Okay? Yeah. 1, so we want this to be less than 1 to start. You have to leave, that's too bad, but I hope you had a nice time. So you couldn't stay long. It's no worries at all. I just hope it was good while it lasted. Actually, have a good night. Thank you. Now that I think about it. It could be XZ, right? And then over here at Y, we have, perhaps it's a vector 2 of X and then vertex dot Z. Yeah, plus PTH Z. And this is why I was going diagonally before. Offset X. So now, this needs to be at 1. Wonderful news. If I could have this be like inverted so that it's 1 over, then that would be better, I think, but it's fine. Boom. Let's put out a nice 1.5. Right? Not right. 0.3. 5. Okie dokie. I forgot to turn the music back on. So I will do that. That's good. Hold on a second. Darn it. Okay. Hang on. Let's see what that... Let's pause the music again. Because I bet that video has more to say.
There's a pretty obvious problem with this. By just taking the average and minus the texture. To solve this, we'll have to use the mesh's normals. Right after we assign vertex, create a new vex3 variable called normal. First, let's copy and paste the definition of vertex. Except, we want to replace the vertex constant with the normal constant. Then surround the entire thing with parentheses.
Okay.
Just put the xyz values in our normal variable. Surround it with parentheses again, but this...
So we'll try that to help. Or we'll continue following along to try and help things a bit. You know? It's important that it lines up, right? Inverse view matrix normal vector 4 normal 1.0 dot xyz. And this one is normal. And then, yeah, normalize. Okay, so it's normalized. Whoops. The whole expression. Can't multiply between material for an XYZ, huh? Okay, let's do it different. Oh, gotcha. There is actually another parenthesis here and another parenthesis here. Should be fine. So that's like that. And if you, okay, let's try and just toss this thing and start from the top. Alright, so we put parentheses around this. I think it does need to be vector 3. But dot xyz. And then say normalize the expression. There we go.
Variable called adjusted normal. Right now, this is just going to be the absolute value of normal. To figure out which texture we want to use.
And then we will have what? Vector 3 adjusted normal. And that is the absolute value of normal. Alright. Yeah, I'm going to take a quick little 3-minute break. I'm thirsty, my water's empty. So I'll be right back with that. Okay, I'm back. Let's see. I'll probably pause this again. And then...
So let's create a new vector called weights. This is going to be equal to the adjusted normal divided by the sum of all of its components. Each component of weights is going to tell us which direction we consider most important. To use this,
weight adjusted normal over adjusted normal dot x and adjusted normal dot... Yeah, okay. And that is a what? Vector 3. Y Z times 3. Yes.
multiply each of the color samples by the corresponding value in weights.
Okay. Hmm. Oh. Huh. Times 3.0 is perhaps important. There we go. Has to be a floating point integer. Then we multiply by weights. Oh, that's interesting. It's colors now, huh? That's not expected. Let's see what I did wrong.
So this is the result we end up with. The textures are much less muddy, has smooth transition between them. Next, I'll be going over how to have separate textures for each axis, and how to make the blending between different textures look much nicer. First off, though, what are the advantages of having different textures on each axis? The most obvious texture before is terrain.
Okay, so that's not what we want. Yeah. We're close, though. We're very close. I don't think we want to... The reason I don't think we want to add weights is because it changes the color, and I don't think in a good way for us. Whoops. Right, so right now the issue is that it does not hold true, you know? So I'm going to figure out what INV view matrix is. So we can try and make it use global position instead of local position, maybe? Something like that. Doc Godot. And I left my water downstairs, by the way. So, oof. Let me find Godot forums, right? Not forums, docs. Yeah. IMV build metrics. Sure. World position can be constructed from the depth cluster using this. World position goes world XYZ over world W. Okay. Let's try this. Alright. I'm trying to use a world position for the texture. NDC. What is that? maybe, hang on. Maybe NDC is declared up here equals screen UV on depth. Okay. Maybe we try using vertex for that. See if that helps. Right. And then, what if we said it does seem like the only one that matters is the Y position, right? Oh, but we need it for the color. Ah. If I were to remove X from there, what happens? Nothing, huh? If I make this just color Y, what happens? Actually gets better, huh? Oh? Oh, I see, I accidentally moved that around, huh? Okay. So we don't actually need color Z or X, I think. Instead of deleting them outright, I'm gonna comment them just in case. I'm a little worried about that. But now, what if we make a second version of this, right? UV test equals vector2 world.x plus pth offset vertex z, not vertex, world.z plus pth offset z times pth. Okay. How's this? Oh, not vector2. I can't type it out. It has to be this way. And then we have a vector3 color test equals texture top teeth text and UV test dot RGB. Right, and then if I put color test here instead, what happens? Okay, I guess that's to be expected. And it's the same thing, except it includes something called in-projection matrix, huh? Okay. Actually, what if it was just a projection matrix? I don't know why. It's a circle. Okay. Interesting. We'll fix those later. We just need it so that they move with the transform of the object, right? So let's remove the testing ones and these world variables. And then say, what if hang on. World position can be constructed from the depth buffer using this code. Using the view matrix transform from view space into world space. Okay. So I think we do want this here, right? And then we need to define NDC. Because we don't know what kind of render exactly it uses, so go like this. And then we also need one for a variable for depth, it looks like. And depth, for the compare, I guess we just use this then, for simplicity. We'll fix it later if we need. We still need depth. Yes. Depth texture and screen UV dots. And then we need to find out what depth texture is. Hinge depth texture. Okay. And that goes up here then. Okay, so we have world position here. That is a good thing, I think. I think that with world position, we can put the what is vertex anyway? Looking for specifically vertex in all caps. Guess not. Done. Well, we'll keep this page for a bit. But this is a vector 3. What if we, instead of vertex, tried world position? What happens? Okay. Tricky. World position times where I was about. Okay. What if we normalized it? Okay, so it's looking funky, which is good, I think. What if we remove the projection matrix? Okay. Now this is really similar to what vertex was before. Oh. So this is good, but it doesn't get us something that moves with the mesh is the thing. Right? And we want this vector 3. What if we just tried, I don't know, golly. Doesn't look like that's something I'm supposed to do, or else it would be there. But what if we tried adding the world position instead of multiplying? Plus world position dot x plus world position dot z. Okay. Does it depend on my view? It does. I don't like that. I don't want it to depend on my view. Oh boy. So then probably trying to get the world position isn't gonna work. Probably let's see what they were doing, I guess. No, but that doesn't work. Golly. If I rotate this, they just kind of fall off, you know? Wait a second. Also noticing it darken, which we don't want. You know? So over on Toon Shader 1, we're going to add a uniform vec4 albedo source color. And then we'll copy all this for the lighting. Color gradient needs to exist. Okay. And color gradient is going to be a new 1D. And if I remember correctly, it should go in just to the middle and a half. Okay, now when I do this, it does seem better. But the problem is, now the images are too static, right? I need them to transform with the objects transform. You know, which is hard. So let me see. Full screen. Okay, hang on. Okay, so let's try changing it to be vertex.xy really quick. Alright, because I'm pretty sure it's using the wrong one there. Okay. Interesting. So that goes and makes it worse. Interesting. What if I remove X and make it 3 1s? Yeah, I should have expected. Okay. Okay, well, what if I just do vertex then? Gotcha, so that's only a vector 3. This is why it needs the 1 point. Oh. Makes sense. Okay. Then, so the normal goes like this. I think it was times weights there. Maybe. Let's go double check what it was previously. Yeah, I accidentally kept skipping past it. God.
Hello, I'm Jeffrey. Today I'll be going over a technique for texturing meshes called triplanar.
Let me just look up triplanar meshing, or triplanar mapping Godot. Right? World coordinates as you to know about all this. It's hard. All I need is for it to move with the transform of the object, right? So I'm gonna see if I can do that. To shader. Um, Golly. Hmm. Um, well, we're at an hour and 40 minutes. I think it's gonna be best to call it for today and do some more research on my own time, and then we can come back maybe even just tomorrow and finish up then. So I'm gonna, yeah, send y'all away. And, I hope you guys have a really great time. And I'll definitely see you guys tomorrow. We'll see who's online that I can raid you into. Alright. Uh-huh. Here, we'll go this way. And yeah, I'll see you guys tomorrow.